Welcome to ARVN, Amateur Radio Video News. The program you're about to see is free to watch, courtesy of YouTube. Thanks, YouTube. But it wasn't free to make. ARVN's got a lot of money invested in video equipment like this sweet camera and that editing system back there. And it takes a lot of time to shoot and edit a program like this. So I'm asking you to make a voluntary payment, contribution, whatever you want to call it. Just stop by our website, arvn.tv, and you'll see a link to make that payment, whatever you think the program is worth to you. I guess you could say that this program is brought to you by you. So thanks for watching and enjoy the show.
Okay, I'd like to introduce Bob Bruninga WB4APR. Bob's going to be talking about a shadow ad hoc temp-in-n network from Maine to Georgia. Take it away, Bob.
Thank you. I had to invent something to get an opportunity to talk about APRS again. So this is what we came up with. We're going to do a little bit of APRS 101. You all know that the thing that separated APRS from pass packet was simply going back to just raw digipeating as opposed to node-to-node level 4 networks. And so everybody could be a digipeater. Homes could be digipeaters, and then we started putting up the wide digipeaters. So I'm going to start going through some history. And this is the original DOS screen, kind of showing what's going on in Baltimore, Washington, Annapolis. And you can see where the big digipeaters are. And of course, fundamental APRS was that in addition to your position, the next most important, there's two more most important things you need to know about communications. And that is the height of your antenna. We're all VHF hams, so we know that the height, how important that is. And so the height and gain and directionality of your antenna was all included in the position report. And then in about the year 2003 or 4, we realized, duh, you need to know what frequency you're on. Now you say, well, wait a minute, that doesn't make sense because APRS was on one national frequency. Well, remember, the purpose of APRS never had anything to do with vehicle tracking, position, maps, or anything. It started out as a common channel for all the AMRAD guys in the Washington, D.C. area to just, when you went down to your shack and you were working on something, you'd send out a beacon. And everybody was monitoring. And so you'd see these beacons coming across the air. And you'd know that, you know, Terry Fox was in his shack doing this. Or and so forth. So you got an idea of what was going on the air. And of course, that was back in the 1978 time frame. But soon, you know, then somebody came up with a BBS. So now you couldn't just sit there and monitor the channel because all these packets are flying by, and once every 10 minutes, you know, a beacon, you wouldn't see it anymore because it was just lost in the crowd. So I said, what we need is something that sits here and just captures only the beacons and ignores all the BBS traffic so I can see who is on the air. The whole purpose of APRS, common single channel to just look and see who's doing something. Had nothing to do with position reporting. So, like I said, in 2004, we added frequency because we realized this. The 144.39 data channel is where you put your information. But the number one thing is, well, how can I contact you? What voice frequency are you monitoring? Because anybody that's on APRS has got another radio in his car that he's talking on a repeater or doing something, or he's doing something on HF. Anything you're doing in ham radio, we wanted to see a beacon on the APRS frequency just so that we would have a community of what we're doing. In the Washington, D.C. area, I believe there's 50 clubs and 100 different repeaters. You can't scan all those repeaters and keep up with everything that's going on. So the idea was just look at your data screen, and when somebody does something new, you see it. That all got completely lost when we connected GPS so that we could see where people were in the network. The positioning in APRS was never meant for vehicle tracking. It was meant to be able to visualize the network and see the connectivity. I'm going to ramble all over the place. But anyway, sometimes, you know, the APRS channel is pretty busy. And so also sometimes it's hard to get anything done because all the grass or you know, the lower level of noise going on because everybody's transmitting that they're not doing anything. And so we have all these, the lights are on, nobody's home, and it's very frustrating to me because I can look at this map full of, now this was about 10 years ago, this particular map, because you can get into the old APRS DOS with the hand-drawn maps. But the fact that 90+% of what I see on the map is machines or mobiles. I have no idea what frequency he's on. I can't contact him. To me, it completely lost the concept of amateur radio. So, going the wrong way. To get back on track, the thing about setting up an ad hoc network is realizing that you used to need a radio and a TNC and then set up the TNC and everything else. Well, for now over a decade, we have ham radios that have APRS built into them, and right now there are 3 of them. They're all Kenwoods. Yaesu has 2 very good APRS radios. I don't have the other one on here, but I was very surprised to see that their mobile did not digipede. And in fact, that killed us at Scout Jamboree, once every 4 years, because Yaesu donated their new APRS radio down there for the main thing. And so we had people that were going to drive all around, people have trackers and everything else. And we found out once we got there that that radio doesn't digipede, and so we didn't have a backup plan. So I got to learn this thing. Keep going this way. So this is digipeding 101, and all TNCs will digipede on my call. So if you just put in a path of somebody's call sign, their TNC will digipede it, put a star on it, and the packet goes out. Now, I see that all the original people are still here in this room. But I'm getting old enough now where I don't trust my memory for anything. I'm saying that packet became legalized in '78. Paul, Ronaldo?
Thereabouts.
Thereabouts? Okay. I think initially you had to have a separate ROM if you wanted to be a digipeder as opposed to a user. So I'm saying within 2 years then all the TNCs could also be a digipeder. If anybody wants to correct these things, let me know. But then from 1980 to 1985, boy, did the packet take off. NetROM, DNet, what are all the other ones? Rose Network and so forth. And the #1 thing they did is we're going to outlaw beacons because beacons don't tell us anything. Well, to me, they tell me everything. I don't want to see all this other connected traffic. And then they basically turned off digipeding in all the nodes. So now the only way to do anything was a connection, and a connection, and a connection, connections and ACKs going all over the place. And the channel was mostly loaded down by overhead, and hardly anybody was communicating except a guy was reading his BBS from 3 hops away. Very frustrating because it was very hard to then communicate with a human. Everybody was checking their mail and getting off. And so we kind of lost, again, the touchy-feely, real live ham-to-ham operation. So then in about 1990, all the way throughout this entire time, I was still doing APRS-like stuff. It was called Connectionless Emergency Traffic System. And it was simply recognizing that I want to, at a special event or the National Emergency Disaster Exercise, whatever that was, we wanted anybody who had a bit of information for it to go to everybody. And so that was my first software, and it was back in the 1985 timeframe. So that's really about when APRS started. And it was, again, using a one-to-all protocol so that everybody got a copy of everything that was going on, and anybody could transmit. But what we found out is if you use just this generic alias, we made every TNC then be a relay, so it could relay for other people. And you can see that as soon as you go more than 1 hop, 2 hops, you're exponentially blowing up the network. And so that's what we did for the first few years, and we were clamoring back in 1994 is when I said we need something that will recognize it's digipeded a packet once and not digipeded anymore. So PACOM came up with I think he called it additional aliases, by the way, but it was call sign substitution, so that once you used up the generic path, the TNC inserted what the call sign was of that TNC that digipeded it. So now not only did we have traceability, but we still had generic pathing. I should have put relay down here just to make it easier. Of course, that's what's fundamental to APRS is the path is generic. Just anything that has that matching path relay this. So the problem with this one is it does call sign substitution. But you'd have to do mobile, 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 mobile to get 3 hops. And again, once it's done its call sign substitution, then that station will not digipeat that one again. So we had dupe suppression to some degree. But we wanted the packets to go further. So we added in 1998, and finally Cantronics was the first one to put that in. If I send out a path wide 3-3, well, initially we said wide-3. And what we said is every TNC that hears that will digipeat it once, decrement the number, and then never digipeat that packet again. So we had full dupe suppression and multiple hops. But then what the problem we noticed with that is eventually that packet arrives as a wide-0, which is just wide, and you don't know how many hops it took to get to you. So almost immediately we changed it and said, this 3 is not part of the algorithm. It's just a character that's a dummy character not used. So what you do is you put the what you desire out here, which is where the algorithm works, but you put what you started with here. So that when this packet arrives, it eventually arrives as wide 3-0, or basically wide 3, but you know it started out 3 hops away, no matter how it got decremented to get to you. So that was basically that was called UI flood, because as the packet propagated, the ends were decremented, but the packet didn't get any bigger. And so it could go long distances. Well, it didn't take very long for that to totally saturate the network too. So I'll get to that in a minute. But that's the way we were all the way up until the mid, early 2000s. And what we realized is we really need to have the network traceable. So at the same time they put in UI flood, they put in UI trace, which is the same thing. It's just that every digipeater that decrements it inserts its call sign in here. So the packet always arrives now with the digipeaters that were used to get there. But again, full dupe suppression. Anytime it hears other copies of that, it will ignore it, so that every digipeater only does it one and only once. The problem with the UI flood, not a problem, they did have ID enabled, so at least you could turn on ID. And remember, back then we were using 5 and 6 hops to get from here to Georgia, for example. UI flood, like I said, is not traceable, but with UI flood ID enabled, it will insert the digipeater call sign of the last digipeater that digipeated it. If the next one digipeats it, it will overwrite its call sign with that one. So these packets always arrive with 2 fields, and that is this thing decremented plus the last digipeater that was used. The problem I didn't like about that is I already know what the last digipeater is. That's the one outside my window, up on top of the neighborhood. What I want to know is, where did you come into the network? Because I've got to know that to get back to you. Well, by then, I couldn't get anybody to listen to me except Kenwood. Kenwood finally did, and so I got them to put in an option on UI flood that says first. And if somebody transmits that, then the first digipeater inserts its call sign, and all the rest of them then do not. So you can see how it got into the network. Now, yeah, let's see where I'm going next. I don't know. Okay, so how then do we use those capabilities? And to cut down on the network blowing up and everything else, in 2004, we said, okay, we're starting over from scratch. Back then we had relay and wide and trace and wide in and trace in. We had 6 different possibilities the way to use this system. And of course it was confusing to users, therefore it was confusing to teach people. Therefore we were getting, it was just bedlam. So we went back and said, there is only one and only one path. It's wide 2-2. That means your packet is going to go out 2 hops in all directions, and there's none of the digipeters are going to duplicate that because they have dupe suppression. And you've basically filled in your neighborhood and metropolitan area. And APRS shouldn't be going any further than that, because otherwise you're spamming other areas that you have no idea what you're adding to their network. So nationally now we say nothing bigger than 2-2. However, the problem with that is, this line that I've drawn in here is retaining the fact that any TNC can do the top types of digipeating, and only the new, Cantronics, Paccoms, Kenwoods, or any of the other APRS digipeaters will do the automatic decrementing of the SSID. So the problem is that hams don't like to buy anything new. So, and they had this digipeater that they've always been using up on the hill to get them over the hill, and they wanted to still be able to use that. So what we realized was if we make wide 1-1 be just a generic, put it in quotes, that is the call sign, then these, put that in as an alias for these older TNCs, then they can digipede it once, mark it as used up, and then the packet will go from there on into the decrementing network. And you say, well, that's what we used to do with relay. It used to be just relay here and then get into the network. The problem with that is if the relay and this hits a major digipeater, it's going to do, there's no dupe suppression. So anyway, what we came up with was this allows the wide 1-1 to be digipeded by any old TNC. So we call those fill-in digipeaters. You live down in the valley, all you got to do is get an antenna up another 100 feet and you're in, so you set up an old TNC with a wide 1-1 alias. The advantage of this system is that if this also hits a wide area digipeater, it's going to go ahead and accept that first one, decrement the 1 down to 0, that's used up, and then it'll move on to this one too. So the fill-in digi, if it hears you, will relay you, but if it doesn't hear you, the main digipeater will carry on. Because remember, in AX25 packet, these things only get used up one by one, and you don't move on to the next field until the earlier one has been marked as used. And so there never was anything called preemptive digipeding that says just pick anything in the list, and if it matches you, then use it. That was another idea we promoted. Some of the people put it in there, but we began to think that's not a good idea. Let's see what's next. So here's what I just described. This guy is using the, now I bumped it up. This, when I said home stations use this because you don't usually need a fill-in digi. If you do need a fill-in digi, you know what it is, and you can use its specific name. So the fill-in digi is only the generic thing for the generic mobile. So we said then for mobiles, then you get to fill in this wide 1-1, wide 2-1. It gives you a total of 2 hops, because remember, we don't want to have more than 2 hops in most areas. So that's typically what we recommend. However, just to keep it simple, notice what we're doing is, remember, this numeral is not acted upon. It's just there. So we put 2-1 in there so that when it arrives, this has been starred, and this arrives with a 2 star, and it looks like it only went, that it went 2 hops. But I'm going to use an example here of a guy doing wide 1-1, wide 2-2. And I thought I erased this. Oh, I didn't go back and fix it. Forget this little path here. That one doesn't exist. This guy, his path hits this digi. It gets the wide 1-1 gets used up, and then what's left is wide 2-2, which is this digi, which then decrements it to 2-1, and it gets to this one. And then the 2-1 gets used up, and it's 2-2. However, if that same packet happened to hit this digipeater direct, it's going to get there before this one does, and it'll be the 1-1 will get used up, and then 2-2 is remaining. So then it goes through this one, 2-1 is remaining, goes through this one, and arrives as 2 star. So notice that the packet takes the shortest route, and these never appear because this digipeater, having heard this one first, will say, I've already seen that packet, and I will not repeat it again. So that's kind of how the wide 1-1, wide 2-1, or wide additional path is used. Clear as mud. Now, here's why we don't. Back when we used to use, this is showing you if every digipeater in the metro area can hear 4 other digipeaters, which is not unusual. That's probably pretty typical because everybody wants to put up their digipeater. You can see that when the first packet goes through wide 1-1, or is transmitted as wide 1-1, it's going to have 4 copies because 4 digipeters heard it. If you have 2 hops, it's going the first 4 are going to hear it, and then each one of those has 3 more digipeters beyond it that hear it, so 4 times 3 is 12. So for a total of 16 dupes, go out in the local area. 3-3 though, you're up to 36, 4-4, 64. 7-7 is 196 copies of that packet, all up and down the East Coast. And that's what was killing us. And that's why back in 2004, we just said nothing above 2-2, and it really, really brought APRS under control. Now, this is something somebody plotted out in San Francisco Bay Area, and he said, let me take a plot of all the packets heard, and I'll plot in purple all the ones that were heard on the first hop, blue all the ones heard on the second hop, and yellow for all the ones that were heard in 3 hops. Now, you see there are a few 3-hop ones, but that doesn't mean you can't get out of here or here with less than 3 hops necessarily. Maybe when that guy transmitted, it collided immediately with something else that was stronger in its area, so it never got through until after that one cleared and it hit another hop and another hop before it got there. But anyway, we use this to convince people that there's just no place on Earth, basically, where there's any APRS that you really need more than 2 hops, unless you're in Mississippi. Now, so here's kind of what we were seeing. This is my house, somewhere right in here. That's West Virginia, so I'm right about here. This is what I was seeing every evening on my screen when I came home. I was seeing not only every digipeater on the East Coast, but just about everybody else. And it was just totally meant that the channel was saturated. So in addition to cutting back on the N-N, we still said, but you might need to, for ARES RACES in the Maryland area, you might need to contact everybody in the state. But look at the shape of Maryland. You know, if you went 5 hops, which is what it would take to get from Ocean City to Western Maryland, you would also QRM probably 13 states on the East Coast. So since every TNC has 2 mechanisms, remember there's the UI flood, which does not trace, and UI trace, which does trace, and we've homed in to where every digipeater now traces, but only 2 hops. We said the UI flood, let's go ahead and use that for SSN-N, where S stands for your state or section. In this example, I used Maryland, DC. And so if I launch a packet anywhere in Maryland with the path of MD7-7, it doesn't matter, it's going to hit every digipeater in the state once, because remember, they all do duplicate suppression. Everybody in Maryland will be alerted to that bulletin that went out, and we eliminated all this QRM. So that was another big step. Now, here's something that we came up with. Again, nobody's listening to me anymore, so the only person I could get to implement this was Kenwood, and I said, APRS is not about making cute little tracks on maps. It is about participating in a network, and when we participate in a network, we have certain expectations of how long has it been since you heard from somebody. And so I like to have the once a minute thing. If there's somebody driving down the highway near me, I would kind of like to hear him once a minute to kind of see where he is and know that he's still in range. So this is called proportional pathing. And that says is if I set a 2-hop path, oh, by the way, so the Kenwood D710 mobile and the HT comes with this by default now. That means every other packet I send is direct. Doesn't go any further than just 1 or 2 miles, so it does not QRM the entire network. Now, every other packet goes 1 hop, and so that kind of fills in my local area. But now if this is once every 1 minute, this is once every 2 minutes, and every other one of those goes 2 hops. Okay, so once every 4 minutes, everybody in the metro area sees where I am. Once every 2 minutes, everybody in the county sees where I am, and once every 1 minute, everybody within 1 or 2 miles simplex of me sees where I am. And it's this is, to me, the real value of APRS is what's going on in your immediate area. You're driving down the road at 70 miles an hour. The other guy's driving at 70 miles an hour. And at 140 miles crossing, if that other guy has said, well, I'm going to cut my packets to once every 4 minutes so that I don't load the network like this, or I load it no more than Bob's doing, he could be doing once every 4 minutes at 140 miles an hour. What is that? Once every 5 miles. And if anybody knows what your simplex range is mobile, it's less than that. So you can pass each other, not even see each other. So that's why I like the proportional pathing, is because within that 1 mile range where my proximity detector is operating, it lets me know when somebody gets within that range. So that's proportional pathing. Now, the purpose of my talk today is temp n-n digipeating. And the whole concept is, if we go back to the that slide, is I want every mobile radio that can do it to always be enabled as a mobile digipeater. The problem with that is, well, even if you enable it once for a special event, the guy's going to forget to turn it off, he's going to forget to disable it, and now for the next 6 months or 6 years, that thing is driving around out there, replicating every packet on the network and destroying the network. So I finally got to the point where it says, we don't want you to do any temporary settings for a special event. We want the radio to already be configured. So we came up with temp n-n digipeating. So all we do is we say, since these radios are basically turned off for digipeating, wide n-n because it would destroy the network, we say enable every one of these radios from the factory to do temp n-n digipeating because nobody uses that. For routine operations, that path is never used. But if anybody, anytime, anywhere, sees you on the map and wants to use a digipeater, he can just do temp 1-1. He'll hit your car and you'll go out. He didn't have to ask you to turn on digipeat. It's always been on. It's always in there. And that's the topic of this talk, the shadow temp n-n network. It's out there. And in fact, even on 144.39, you can attempt to transmit a packet via temp 7-7 and see how far it goes. And it probably won't go anywhere, because if you've ever looked at the map and how many people are in simplex range of you, it's probably 0. For the VHF, the reason I asked for this slot, the VHF VHF QSO party contest was last weekend, or weekend, the 10th of September. And I thought, wow, this would be a great opportunity to say, in addition to all those VHF contesters up there, anybody that's driving up there with a Kenwood will also be a digipeater. And so we will not be using any established infrastructure, but we can digipeat from anybody that's in the contest. It turned out I didn't go up to the top of my mountain, and a lot of the other people who have their favorite mountain, they didn't go up to the top of theirs. And so the two of us in Maryland that tried this, we couldn't even hear each other. Okay, so, but the point is that it's out there. It can be used anytime that you're out of range of the existing network. If somebody will just drive their D710 or D700, the difference is D710 comes with this built-in factory default by Kenwood, so we know it works. The D700s, I'm asking everybody, hook up your PC to your D700, program it once to UI trace temp, and that turns it on for temp n digipeating. And it won't bother you at all, but you will be there then when somebody else needs you. Now, if you really only want to go by one guy's car just to get into the wide network, then you really can only use temp 1-1. If you did temp 2-2, the second hop will never get used up, and it'll never get to this second one. So, so this is one use, where you want to use it just to get into the existing network by going via the nearest D710 or D700. However, if you're a field day or the entire infrastructure has been knocked out or anything else, and you want to establish an emergency network via every D710, D700, or any TNC that anybody else enables this on, then go ahead and do 7-7 and just see how far you can get. Now, to see how far I can get, Paul Ronaldo and some of the early APR, AMRAD folks remember that back when we saw that AX25 was really going to take off, and before VNets and NetRoms and all those, who's going to be the first person to get a packet all the way across the country? We're going to call that the golden packet. And AMRAD was going to offer an award. Well, it wasn't until the next weekend that somebody says, I'm getting packets to San Francisco. Well, how'd you do that? Well, I'm using this new thing called the internet at work, and it's, And that was the end of long-distance AX25, because now everybody put up wormholes, and of course now we have everybody's got the internet, and everybody's TNC and radio, and they're all connected to it. And so nobody has ever claimed the golden packet prize. And so since it's now 20 some odd years old, I thought, why don't we do this? And of course, we got mountains here on the East Coast. They're a lot older than the ones out west. They're not as tall. But it turns out if you go along the Appalachian Trail at about 100 miles a hop, you can, using Google Earth, Whoops. Okay, so anyhow, we came up with this idea of why don't we have the golden packet event? Because I've been taking packet to field day for the last 20 years, and you don't get no respect. Nobody gives a hoot what you do. They just kind of look at that and say, oh, that's APRS. You know, everybody's here. They're in the parking lot. Why do I need to look at this map? I said, but I'm talking to the world. Well, so are we. We got HF. Starting back in, well, 3 years ago now, we said, all right, forget field day. We're going to have our own event, and it's going to be called the Golden Packet Event. It used to be the Appalachian Golden Packet Event, but I said, wait, if we can do it here, they can do it on the Continental Divide Trail, they do it on the Pacific Crest Trail, do it on the National Trail, you know, the Lewis and Clark. There's 50,000 miles of national linear trails in the United States. Wouldn't it be neat if all the packet guys, you know, once a year would go out and just see how far we can establish an ad hoc network? So this is what we came up with, and let's see if my next slide does what I want to do. No, it doesn't. Everybody use Google Earth. I mean, you could zoom into the top of a mountain and pick the rock you're going to sit on. Okay, and then you could go down to that level, bring the map down this way, and you can look all the way around, and you can pick your path to the next mountain, line of sight. It's just, in fact, we had so much fun, you know, shack potatoes, that the event itself was no fun because we'd already visited the top of every mountain and, with Google Earth. So we came up with this, this 15 stations, 14 hops. Now what's magic about that? Remember we always say wide 7-7 or temp 7-7. You can't go any higher because then the path gets filled up in the AX25. So guess where I happen to, it's not 8. That's New Jersey is really up here. I go about 50 miles north of here, and I climb a tower, and I sit up there. So I get 7 hops either way. These guys have to do 15 hops. And the path we use is, well, I'll get into that. So what do we take up to the mountaintop? The simplest thing is just a D700 and an antenna, and now you are a digipeater on top of the mountain. Everybody can see you, you can see everybody else. But we always say, take along one of these, because we're going to do this on a special frequency. You know, sitting up there otherwise with 144.39, we wouldn't get anything through, because, you know, that channel is wall to wall all across the country. So for that one day, with or without permission, we go down to the balloon packet frequency, and we just make a lot of racket. But we say always take your HT with you, because while you're sitting up there trying to establish this ad hoc network here, remember from your HT on 144.39, you can talk to anybody on any mountaintop anywhere in the world, because it just goes into the 144.39, goes into the internet, comes out the other end. And so we were all able to, this is our back channel for coordination, but the whole objective is to try to do this. Also, of course, it's a dual band radio, so operate band B on the APRS UHF simplex frequency. And then you could be coordinating with your 2 nearest neighbors. Are you working yet? No. You know, this caught on fire, that, whatever. Now, we picked sites that mostly can be done by an Omni, but a couple of them had to have beam. And all I did was put this to show you. Remember, 2 75 ohm quarter wave pieces of coax will allow you to couple 2 antennas together. And 1 or 2 sites did that. Also, how are you going to power it? And did the calculation. Oh. This was an attempt, so there's no reason for sitting up on the mountain for 24 hours to make an attempt, when if everybody had their act together, we could all go up there, transmit the packet, and go home. I'm always the last guy, and so so we made the event be 4 hours. It starts at noon, and by 4 o'clock, we're all going home, whether we're successful or not. And so running this radio, digipeating, you know, appropriate number of times, you can do that with about a 7.5 amp hour battery. I also said carry up a solar panel and you know, just a 1 amp hour battery, and you could operate as long as the sun's shining. I should tell you the amount of rain on the first day. So what we used on the Appalachian Trail was, I did not want, remember, we don't want the operators to ever change settings in their radio that could screw up the APRS network. And by the same token, I did not want to mess up the temp N-N, which should already be in every one of those radios. So I said, keep your UI trace set for temp N-N, but now use UI flood, which we always want off for every user. You know, that's only for digipeaters. set that to support a hop N-N network. So that's basically what we used for the whole network was to go from one end to the other, you'd have to do hop 7-7, hop 7-7. It would take 14 hops to get from one end to the other. Now, how do you set up temp N-N digipeating? The command is UI trace. It's just a TNC command. And the word is temp. Because what you're saying is, this is the key word you're looking for. Whenever you see that word, take the dash number and decrement from it. However, remember this N is just included for fun because it has to have the 7 to show you that when it gets to the other end that it actually started as a 7. But again, you don't include all that. You just put the word temp, and that becomes a temp N-N digipeater. UI flood, hop, makes that into a hop N-N digipeater. Remember, the difference is that temp traces. We couldn't possibly trace a 15-hop path because the packet would become this long. Well, in fact, once it gets above 8, it just doesn't digipeat anymore. So this is UI flood, which means each copy does not carry the path forward. All it does is decrement. Okay, so now I'm going to show you how many of you are not from the East Coast, within 100 miles of the, okay. I just love maps. Geez, I wonder why. This is starting at the start of the Appalachian Trail on Springer Mountain in North Georgia. We get one shot to Klingman's Dome, which is the highest spot in the Smoky Mountains. And from there, Klingman's Dome to Roan Mountain, which is a very, very high mountain and has a park. All of these are drive-up spots. You just drive up there, park there for 4 hours, and you're done. But these guys made the mistake of asking for permission. You know, there's a parking lot up there with 300 tourists on any weekend. These guys asked for permission to use for a ham radio event along the Appalachian Trail. Boom! Fireworks went off. The Appalachian Trail Conference in West Virginia contacted me and says, you cannot have an event on the trail and without paying a $100 application fee at every park you go through. He says, you know, it's just ridiculous. You can't do that. And I said, but you don't understand what event means for ham radio. It means one car, right? So eventually I got him all calmed down, and he said, well, just don't call it an Appalachian Trail event. And so we did that and got away from it. But that first year, these guys had contacted their local ranger, and they never got up there. Okay, Roan Mountain, you see this is Tennessee, North Carolina, kind of there. The next one up is Comer's Rock. No, Comer's Rock. Beautiful little place I found. Little small state park, you know, 3 or 4 picnic tables right up there, and you got a little concrete bench to sit on, and you can see 360 degrees in all directions. AO Mountain is the DX heaven for Central Virginia. It's got an FAA tower on the top. It's got a 1 kilowatt beacon, you know, on 2 meters. Well, guess what that does to trying to do a special event to get, but anyway, I won't belabor you with that one. Then White Rock. This is the only one that we couldn't find anywhere else to get up here, was West Virginia. And this year, that was the first year, they had to climb all their gear up about 3 miles up from the parking lot. So this time they went to Hogbill, which is only 600 feet from the parking lot. And it turned, I made it red because this was new, and it turned out this works just fine, so they're never going to climb that one again. Maryland Mountain, we've got an ace up there. Dick W. Oh, geez. Anyhow, he's got a 170-foot tower on top of the mountain with an HF. It's got everything up there. So we just say, put your rig on 144.34, done. Okay. So that one's nailed. This is the tower that I climb. I'll show you a picture in a minute. All of these sites we found by just Googling, you know, zooming in on Google Earth and then picking the mountaintop. From there, GD Hill, Camelback Mountain, which is right up in the middle of a Camelback State Park, which is also a ski area. And then from Camelback, Sam's Point, again, a nice big rock out of the middle of nowhere in the southern Pocomo, I don't know, whatever those mountains are in New York. Catskills, okay. Oh, these are the Poconos down here. Yeah, okay. And then from there, straight shot across the Hudson Valley to Mount Greylock in Massachusetts. And from there, it's a straight shot to Mount Washington. The only problem is you go through the earth right about here. And so we wanted, the first year, we got a guy who we just found his house. We just looked at the APRS map, and said, oh, okay, there's a guy who lives on a little bit of a hill, and so we were going to use him. His D700 died the night before. It turns out we do get enough of a path margin to where some of these packets get through, so eliminate that path. From Mount Washington then, believe it or not, it's a long way. Maine is big. The ultimate goal is to get to Mount Katahdin, which is the end of the Appalachian Trail. And so Sugarloaf Ski Area is a mountain there, and that worked out real well. Now, another thing about Google Earth Maps, this year when I went to look at this new path we were going to look at, I noticed as I zoomed in on this High Point Monument in High Point, New Jersey, you can zoom all the way in and almost easily see people and cars in the parking lot with just normal Google Maps. But has anybody seen these little bubbles? When you see a bubble like that, click on that and it just sucks you in. It goes, and now you're into one of these 3D things. You can zoom around, you can look up, you can look down, you can look at your feet, but your feet aren't there. You can look overhead and come down the other side and see the person standing next to you. It's just, you are there. So that's really fascinating. It's just surprised the heck out. See my shadow? Of course, this is not me. This is the guy who took it. But there's a nice looking lady that was just standing right there. It's kind of cute to zoom in on one of those bubbles. Oh, and then all of these little things are pictures. You click on those and you get the picture that somebody took from that location, and so what the view looks like. You never need to leave your shack. Okay, so here was the fun part about setting up an ad hoc network through the Smoky Mountains. And we soon realized you can't get there from there. You can't go through the Smoky Mountains, even though you've got the highest mountains in all these states. What's in between those mountains is also 5,000 feet high. So your height above average terrain is only a couple of hundred feet, if not negative. So the whole idea is we soon realized, well, we'll go around the Smokies. And then we realized if we always go back and forth across valleys, we can get huge heights above average terrain and get huge lengths. So although we called it the Appalachian Trail event, there was probably only 2 stations on the Appalachian Trail because we would go way off the trail, back onto it, way off the trail, and back onto it. And when you think about it, that one that's way off the trail on the next ridge can see the entire Appalachian Trail in profile. And so that's the ideal place to put a digipeater for the Appalachian Trail, is not on the trail, but 50 miles over on the next mountain. This is what that, again, playing with what was the best route to get all the way up to Katahdin. And is it live or is it Google? Somebody sent me a picture that they took from the mountain up there, Apple Orchard Mountain, and so I just Googled in and went into Google Earth and just moved myself around until it looked like I had the same view, and you can see all the same stuff. And this is the ray trace. Just using Google Earth, you just put a pin here, put a pin at the other mountain, and then say draw a straight line and then connect the path to the ground, and you can see your path. It's just a whole lot of fun. Now this is the one that I man. It is a privately owned public park. The guy left the money back in the whenevers, and it used to have just a handrail up here, and anybody could climb to the top of that tower. It's open to the public. I finally now understand why they put this Faraday cage on the top, because people were jumping off and throwing their girlfriends over and all these other kinds of things. And so the handrail, which used to be at 4 feet, probably back in the 40s, now has been extended up and comes into the top, and the bars are exactly 4 inches apart. Here is, I parked down here and I've got 0.6 miles to go up there, and it's not a topic of this talk, but I string a number 22 gauge wire, fits on a spool about this big, from the 200 volts in my Prius and a ground rod, and then string that all the way up to the top of the tower, and I put one, well, I don't go up there. I put a couple of rods in the ground here, and what I've got then is 200 volts DC, run that into a laptop power supply. Laptop power supplies these days will run on anything from 100 to 240 volts AC, anything from 100 to 330 volts DC, and so you just put any voltage in there you want, and you get 12 volts out, and that's what the whole thing ran on. So I've got a whole web page on it. It's called Single Wire Earth Return. It is the most common power distribution in all other countries except the United States. In the United States, it's illegal by the National Electric Code. You cannot deliver power through ground return. But you go to Australia, any of these other countries, they deliver 100 kW, 100 kilometers, and all they do is just boost it up to 19 whatever kilovolts, put a ground rod in the ground, and no matter how far you go, it's 10 ohms. No matter how far you go, it's 10 ohms. The resistance of the wire is what actually starts to add up. And it's perfectly legal because that whole loop there is isolated. You got an isolation transformer at the beginning, an isolation transformer at the end. All you got to do is just make sure people don't grab the wire. So that's what this site looks like. And the first time, can you believe it? We had laptops, we had bags, and there's my power. And anyhow, we had a lot of fun. The first year, we were almost successful, but we had 3 sites that nobody even got up to, and one guy backed out because of rain. And so we had 3 broken segments. But it was the first year, everybody was gung-ho. The next year, ho-hum, we had more broken links than we like to admit. This third year, though, we almost did it. And here's what we got just in July. By the way, this is the 3rd weekend in July, about a month after field day when everybody's recovered. And here's what we had. Starting from the south, Springer Mountain, we had 2 people. Now, they did not have to have a digipeater because they're the source of one end of the packets. On Kleeman's Dome, we had a mobile up there, a mobile digipeater, and he had an HT. And I'm not sure what the X means. Oh, and he had a side path over to Lookout Mountain in Tennessee. On Roan in the middle of North Carolina, he had a mobile, did not have a cell phone, had 4 people as part of his crew, and he had a log, some station down in the valley that was logging everything that was seen. Comer's 4 finally got somebody up there. All he had was an HT, but that's all you needed because the new D72 Kenwood HT now does digipeating. And so he was a digipeater there. Oh, and this was manned then by students from Virginia Tech. D72. The D7 will not digipede. Okay. Well, the D7, remember, has been out for now 14 years. Okay. Anyhow, they don't make them anymore. It's now the D72, which will do everything the D7 can do. It will do everything the D700 will do. It will do everything the D710 will do, except at 5 watts and not 50 watts. So, it's full duplex, satellite radio, the whole 9 yards. Pretty good HT. AO Mountain, the reason we had problems with that every year is it was already a digipeater site. It had this 1 kW CW beacon, and it had 3 voice repeaters. So what they want to do is just send a guy up the day before, put it on our frequency, go back home and say it was done. Well, that rarely works. And also they said, well, we got cavities. Well, if you drive down Interstate I-81 and you look at that side of that mountain, you're 5 miles away, you can see the antenna and it doesn't hear you. You wonder why, right? So I kept trying to say, no, you've got to get a team and go, 100 yards down from the peak. Instead of having your antenna 6 feet away from all these other megawatts, just go, 100 feet down the hill. And all you got to worry about is that direction and that direction. So this year they did that, and so they worked. The Maryland Mountain guy, remember, it's black because he was unmanned. It was just his home station that we said turn that into a digipeater. GD Hill, that's me. I'm not sure why I made it. Oh, the reason I made it purple was because I got up there. I was the one guy that had my TNC set wrong. And but you'll notice that nobody told me because my 2 adjacent sites were unmanned. They had gone up the night before. Yeah, they went up the night before, configured their stations, and went home. So there was nobody telling me, Bob, we're not seeing you. I was seeing everybody else, from both directions. So I thought everything was hunky-dory. 2 hours into the event, I sent my son over to another little hill. It doesn't show up here. And he said he couldn't hear me. And that's when I realized something went right. Okay, Camelback was unattended. Sam's Point, first time we've ever gotten a guy up there. I've got a picture of him using nothing but an HT, a father and son. Greylock had 2 HTs, no cell phone, 1 guy. This guy didn't even participate. That's the going through the earth up there in New Hampshire. Mount Washington, no cell phone. I'm not sure what's going on. Sugarloaf, he did not have any APRS radio, so I mailed him an old D7. And I said, you're next to the end. You won't be able to digipede, but if you hear that guy, we're going to declare it a success. If you can send packets back and forth to him, and if everybody else sees him, then we'll say, well, we could have heard that guy if he had been a digipeater. And then 1 guy climbed 1 mile straight up to the top of Katahdin with a Yaesu. It's not green because the Yaesu, will do full APRS. It just won't digipede. Now, but we did, so the success was, these are the packets heard. So all the way from Springer Mountain in Georgia all the way up to me in GD Hill, I was able to hear them. And I heard packets all the way down, or this guy heard all the way down to here, this guy heard all the way up to here. Mount Washington was heard as far as me, but remember I was broken for the first half of the event. And then these guys all heard each other, and so everybody was super excited because we had packets end to end, and if it wasn't for the idiots in between, mostly me, we probably would have had it work. So now everybody's really gung-ho next year. Oh, the other thing that made it a success is we had a designated shack potato, KJ4ERJ Lynn, who has lived all the way down to Florida, and he was just so envious that he couldn't participate because he'd done so much work in setting this up. So he was the designated guy to sit there and do the internet thing, which meant he had cell phone, he could communicate with any of these teams, with their APRS handheld. He could set beacons and bulletins, and so everybody was completely informed. Remember, APRS to me is a communications channel. We could care less where the little stars show up on the map. We already know that. His whole idea was, can I send a text message the whole route? Very valuable, because when you got up the mountain and you had no idea what was going on, well, guess what? The first message I got from him was, yours seems to be broken. Now, the other problem we had was these guys, you can imagine what's at the top of Sugarloaf and Mount Washington, the highest points in their state, antennas as far as you can see. Well, it kind of surprised me, even though I'd drawn a point saying, go up to the top of the mountain and, right down here in the parking lot's a pretty good place. They couldn't resist, no ham could resist going to the very top of the mountain, standing there within 10 feet of 100 antennas and trying to communicate. So that's what we pointed out is, you should not have gone up here to the very top of the mountain because everybody could hear him, but he couldn't hear anybody. Well, that's pretty understandable. I said, if you had stopped way down here, you would have been several hundred feet below the peak. You wouldn't have had any RF problem with this. And notice that the path from that parking lot, that way and that way, is all you need. Perfectly fine to give up a couple of hundred feet when you can still see the other end. Same thing on Mount Washington. Instead of right up here, worst possible place, go to the lowest part of the parking lot, and you can still see both ends perfectly. And if you wanted to, and hike down to this nice, beautiful plateau, you could have camped down there and had a great time. The guy on, this is Sugarloaf Mountain, the ski resort, right up here at the top was, we all knew that was the highest point. In fact, he rode the chairlift to the top, got off there, and then walked downhill, because he could just see from the terrain and his compass that, I can still see that direction, I can still see that direction. So he was able to hear everybody both directions pretty well because he gave up a couple hundred feet of altitude to minimize RFI, and I think a lot of times we overlook it. This was the complete station on Sam's Point in New York, and again, guy just found an old antenna mount there. Somewhere in there is an HT and a whip. That's all you got to carry to the top of the mountain. The only problem is, I wish I showed you the rest of you. Here's where all those antennas are. Okay, he was one of the ones that couldn't hear anything. Yeah, there's the antennas. If you put these two pictures together side by side, see the telephone wires? He had problems hearing, and I think they learned the message. Now, another thing, the RF analysis tool that you can download that's free on the internet is fantastic. You just give the location of the 2 points. It draws the direct path, the Fresnel zones and everything else. It tells you what your expected receive sensitivity is and so forth. Now notice that this says it's minus 4.3 dB. That doesn't mean you cannot communicate. It just simply says that you cannot communicate 90% of the time or something, which is its goal. So let's look. That is what is that? Mount Washington to Mount Greylock. That is 235 kilometers. That's one huge hop. Because remember, we had planned on having somebody in between. In fact, we had Sugarloaf Mountain in between. So, but we wanted to see if you could make it direct. 1 or 2 packets were heard direct, but you can't depend on it. Here's one. This path works just fine. It's got a plus 12 dB margin, but look at the line of sight. Well, you're getting knife edge refraction off of that one. And it calculates all that stuff in there, and so that would give you a 12 dB signal margin most of the time. But notice it's only 104 kilometers. And where is that from? Maine Relay, that's in the middle of Maine, and well, Mount Katahdin here is 5,000 feet tall in the middle of nothing around it, so that's why that works. The bottom part of those graphs that I just showed you is this one. It doesn't fit on the same graph. And when I said this link, they say fails because, yes, statistically, the standard bell curve, you will have a lot of times that you can communicate, but more than half the time you're not going to communicate by about 12 dB. This one is the one that has a positive 12 dB margin, and yeah, most of the time you're going to be able to communicate, but 10% of the time down here you're not. Fantastic tool. So this is KA1YBS, and when I say climb straight up, he starts here in the last campground, and if it's not straight up, it's 45 degrees. It turns out this is 4,200 feet from here to there, not quite a full mile. And then once you get up there, of course, he didn't quite dress for it. He didn't realize it was going to be 50 degrees up there. That's why he's hunkered down. But there's his beam. Oh, and he had to carry all this stuff plus his batteries and everything else.
Then Maine, where? What's that?
What's that? Maine. Mount Katahdin in Maine. That's the end of the Appalachian Trail, and everybody gets their picture taken up here. So the purpose of this talk was to say you can set up networks anywhere, anytime, and if you take it off of 144.39, well, if you're on 144.39, just recognize that anybody with a Kenwood D700 or D710 is already enabled as a digipeater if you just use the first hop in your path as temp 1-1. You don't have to ask him to turn it on, and you don't have to ask him to turn it off for the next year, when he continues to operate it on the APRS frequency. And then you can, again, go from mobile to mobile to mobile. In fact, we have, in our local EOC here, they have an elevated parking garage. And so one of the emergency plans is if the local digipeater goes down, somebody drives their car up, parks on the top of the garage, and they become part of the network. Question?
I believe you've done some tests on
6 meters?
6 meters. Any results?
I'm not the spearhead there, but we have a digipeater in Baltimore, Virginia, and Annapolis. And 6 meters does seem to work very well. And the reason I love 6 meters as a concept is, number one, you can buy 150-watt low-band radios without the control head for, $10. And so put it on the APRS channel on 6 meters. And now you can drive around, have APRS connectivity, and not interfere with anybody else on 2 meters or 440. And when you're at the EOC, if you've got one station talking on 2 meters and the other one talking on 440, you can have as many other ham stations as you want, but they're going to interfere with each other unless you've really done some really good planning. So I think that all emergency center to emergency center, fixed locations, emergency centers to emergency centers, should use 6 meters as their backbones and connectivity and anything else. Leave the 2 meters and 440 for the mobiles checking in and all that kind of stuff. So no, I don't know the performance, but we do get better range on 6 meters than we do on 2. No, I don't see the hook yet.
No, you don't have a hook. Keep going.
Okay.
All right, when they start falling off their chairs, Bob.
Okay. Now, does anybody in here have a laptop that's running any kind of slow scan TV software? Okay. Well, that's free downloads. Okay. Does everybody remembers the Kenwood, what was it called? VCH1. How many people have one? Wasn't that going to be the greatest thing? Imagine. Back more than a decade ago, you got an HT, you can walk around and you can take a picture. And you can take a picture and you can send it to somebody. Ham said, what a stupid idea, A few people did it, and Kenwood said, well, we tried. We made thousands of them, and 10 hams bought them. And they send pictures back and forth to each other, but the ham says, nobody's ever going to be walking around with something and taking a picture and sending it to somebody. That's a stupid idea. Of course, every cell phone in America now has, a camera in it, and that's what everybody does. Take a picture. Wow, look at this. So now you would think that we've had enough of the old FUDs to die that now maybe we could make use of that. I always thought it'd be a great idea to have the little camera, just right up there by your windshield. Driving down the road, you see something going on, snap a picture, transmit it, go straight to a web page, and your position, your lat long, and you grab your APRS microphone and you enter, rec.
All the way down is APRM, which
Yeah.
has been written.
Yes, automatic picture relay network. So the concept was that we ought to be doing that. About the time, and so who said that? APRN. Yeah. So right, the author. So I said, could you please write some software then that would take this slow scan TV image, boom, store it. But nobody knows what it is. The next packet you hear contains the text that describes what that picture was. And of course, you look at the position of the station that sent that text, and now you know exactly where it is. And so the web page is just instantly no hands-on logging of images that hams out in the field are taking with their slow scan TV images. However, try to go buy a VCH1 anymore. And there's about 6 of you that can't buy one because I bought 6. I bought the last 6 that I could find. But again, what's the good of sending pictures to myself? Well, the good news is that one of the APRS cottage industries, Argent Data Technology that makes the Open Tracker, he said, well, there's still a need for that. So you can buy from him for about $65 instead of $500, remember, for the VCH1? Just a little, it's a standard NTSC camera. He puts a little board on the back that turns it into slow scan TV, and now we have a slow scan TV camera, just like the VCH1. It has a little send button, and you can select whether it's a Robot 36. You can select the mode by shorting the pins and everything else. So what I said, all right, I'm going to hook that up to, well,
The VCH1 doesn't do Robot 36. This one only does 35, doesn't it?
Does all modes.
I think it does them all. By default, it does those. But if you hold down this button and count to 10 and scratch your butt, it'll you got to do a lot of buttons, but it'll.
I haven't used it in about a year.
Yeah. So I'll have to admit that I made a perfectly illegal application of an FRS radio. A lot of my experiments now, rather than having somebody on ham radio come back and tell me I can't do that, for $10, the fact that you can buy a UHF transceiver with 22 channels, scanning, PL, CTCSS, digital coded squelch, squelch scan, PL scan, CTCS scan that you can buy for $10, is hard to pass up. So I just have a box full of these, and when I want to throw something together, so here we have a camera. Oh, okay. Let's see how I'm going to demonstrate. Well, first of all, let's turn on the radio. Turn on both radios. I hold it for 8 seconds almost to get them to come on. I'm on the same channel. And do we have audio here? Yeah, got audio. Okay, so now how am I going to, hook up the battery. Here's the battery. Take off the lens cap and focus it for infinity. So let's just put this little camera up here. And now, from somewhere else in the room, from anywhere, now if I put this on the bridge where half the time when I'm driving to work, I see a traffic problem, and if I knew about that about a mile back, I could go the other way. All right? So I've got a $50 camera, a $9 radio, and another $9 radio, and all I do is push the irritating call button. Okay, this thing goes out, with a blah, 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 blah. Have a little 1 transistor audio amplifier, rectifies that, pushes the send button on the camera. The camera says, oh, you want me to take a picture? Take a picture. And then it pulls down the PTT on the same $9 radio and sends me the image back. If I held this up to the microphone on my laptop, I got a picture of what the traffic looks like over the next hill. Total investment, $59 for the camera. I'm not sure the exact price. And 2 $10 radios. My using the call button, see, what I really use these for is when I need to do a remote control. I need to close a switch at a distance. $9, I can do that legally because I'm pushing the call button. Okay? Now, the law says you cannot transmit tones for more than 10 seconds on FRS or some of these other things. Because again, they don't want people to start using those frequencies for remote control. But they've already given me this call button, which fully modulates the 2.5 kilohertz bandwidth. And so 2 diodes of 1 transistor gives me a contact closure at the other end. So that's perfectly legal for me to key this thing up. What's not legal is for me to send SSTV back on FRS radio. But again, if you're a ham and the hams in your club want to be able to, with 50 watts, much further down the road, key up that camera and then sit there and look on their laptop and see what that camera is seeing, it's very easy to do. And this is where I thought we would be 10 years ago with APRN, Automatic Picture Relay Network. So I'm throwing that out. It has nothing to do with what my talk was, but I just happened to have thrown this together a day or two ago for a student who wants to put it on somewhere on the academy, we're going to put it on the bridge and see what it looks like. Now, tomorrow I believe I'll be giving an introductory session for APRS in parallel, I believe, with some of the sessions. But on Sunday, here's the thing that I really want to do at DCC, and I've been talking about it since 2000, the year 2000. I rounded up to 2001 because 2001 just sounds like a better year. That, again, APRS was never about vehicle tracking. It was about communications, human to human. And so as soon as Echolink came on the scene in 2000 or 2001, I said, we need to tie into that. I've got an APRS radio that can display text, call signs, everything on the radio. The radio can send call signs, who I want to talk to, on a packet at the end of every push to talk. So what I wanted, and it was called, what is this one called? AVRS, Automatic Voice Relay System. And that was, if I want to talk to KB2 SCS, the guy who wrote APR, which one? APRN, Automatic Picture Relay Network. He will, all I know is his call sign. I don't know where he is on the planet, but I want to talk to him. APRS knows where he is. APRS knows where I am. APRS can look at the Echolink page and see where all the Echolink nodes are. The Echolink nodes, I finally got Jonathan to add that long to them when people signed up. So now we know where the Echolink nodes are. So now I have somebody who wants to talk to somebody. I know where he is. I know where you are. I can look up the nearest link. I can send a message back to both users and say, you go to 147.105 and you go to 443.2, the nearest Echolink between you, and call each other. And I got so excited about that, I sure it was just going to revolutionize ham radio, that I asked Kenwood, I said, in your next radio, put in the ability to receive a message coming in and have the radio automatically go to a given frequency so that we could do this. All I needed was one person on the planet to write that AVRS, Automatic Voice Relay System, software. He didn't have to ask anybody. Everything was there. He just looks at the APRS internet stream. He knows where everybody is. He looks at the APRS internet stream. He looks for any message that says, connect me to this guy. When he sees that, like I said, he looks up on Echolink, figures out where to do it, how to do it, sends a message to both guys and says, do it. And of course, Kenwood was then, when they came out with the D710, that's what the radio does, and the Yaesu one does also. It will go to a frequency that's included in a packet, but we have the human in the loop. You have to push the tune button. But that's only because we got a chicken or egg thing. The whole goal of that is, as soon as I tell them to do it, you'll be able to set 3 levels of, or a menu that says, if I receive, I'm driving down the road and I don't care what I'm listening to, I put it in the mode that says, if anybody tells me where to go, I'll go there on frequency. So that you're driving down the road and somebody sends you a message and they can just force your radio right onto the repeater that they can see on the map is near you and talk to you. Hands off. It's like a cell phone call. The next mode is if you receive a message that tells you to go somewhere, it'll flash and say, do you want to go? And you say, okay. Boom, your radio retunes to that. Like I say, the radio already does that now. It's just that, again, we haven't implemented the automatic thing. So that's the concept. And like I said, for 11 years now, I've been talking about this, and I haven't found that one person to write that one engine that will do that. So 2 years ago, or a year ago at Atlanta, I was giving a talk, and of course D-Star was on before me, and they got up there and showed how great the D-Star network was. And I was asleep back there in the back, and then all of a sudden I noticed that overnight they had done this thing called call sign routing. Okay, the thing that I didn't like about initial D-Star, and please anybody correct me because I don't use it, so I don't know enough about it. You had to know the call sign. You had to know the call sign, who you wanted to talk to, what your entrance point was, and what his connectivity point was. You had to know all 4 call signs along the way. Well, remember, APRS took off because it says you don't need to know any of that. The network is just generic. It's going to get there. So anyhow, apparently, D-Star now has all I need to know is your call sign. And if you are somewhere in the D-Star system and 0 minutes left. And your D-star node, it will look up where the other guy is, and it will make the D-star connection, and now you can talk to that guy anywhere in the state. Do you have a -5? Okay. So there's the -5.
We're grading you.
Okay. I'm almost done. So I got super excited. I said, finally, they beat me to it. They've got call sign to call sign voice connectivity. All we got to do is make a little piece of software that looks on one side like D-Star, and on the other side it talks to an analog repeater to the APRS guys. Because the APRS guy, you know, his call sign gets transmitted with his packet, so you know who he is. The call sign from the other guy gets transmitted over APRS, so he can see who he's talking to. So we can make the APRS voice repeater look like a D-Star repeater. Isn't that a great idea? Well, try. D-Star says, we don't do that. We do not connect to any analog system because their audio sounds terrible. And so I haven't got much beyond that. There are a few people within the D-Star organization that said, you know, that is a good idea. We ought to work that. But I've also got the other 50 things on my list that I want to do. So anyway, that's what the whole workshop on Sunday is about, is let's get Echolink, IRLP, All-Star nodes, D-Star, APRS, everything, because the ultimate goal is all I need to know is a call sign, and I should be able to talk to any other ham on the planet, whether he's got an iPhone, an Android, or an HT, or a mobile, or anything else. You know, we've already got the APR, the internet connectivity. It's just everybody builds their system vertically, and it can only talk within its own system. And I'm saying that's ridiculous. We've got a universal call sign that works all over the world, so let's use it. I'm done. Thank you.
Okay.